Welcome to Kettle Labs How to series. Today, we'll demonstrate how to enhance GenAI scalability using Mixture of Experts or MOE. Let's get started. MOE combines specialized models with a gating mechanism that routes inputs to the most suitable expert, enabling efficient handling of diverse tasks. Let me walk you through how our Master of Experts works in the RAG process. We start right at the beginning, where we lay out our RAG framework. Think of it as setting up our game plan and making sure everyone's on the same page about what we're trying to achieve. Then we move to expert identification, which is where we bring in our specialists who really know their stuff. These are the people who'll help make sure our assessments are spot on. Once we have our experts, we gather all the data we need. This happens in our data collection phase. This feeds directly into what we call our RAG assessment, where we evaluate everything using our red, amber, and green categories. After the assessment, we put together reports and get feedback from everyone involved. This is super important because it leads us to our final active phase, continuous improvement. Here we take everything we've learned and use it to make the whole process even better. And that's our cycle, simple but effective. In this video, this code implements an expert routing system using OpenAI GPT models and a domain-based classification approach. This class models an expert specialized in a specific domain. The constructor takes a domain, such as healthcare, and a system prompt that describes the expert's role. The GetResponse method interacts with the OpenAI API to generate responses based on the domain's expertise in a streaming manner. The router manages multiple experts and routes queries to the most relevant one. For experts initialization, 3 experts, healthcare, finance, and legal, are initialized with specific prompts describing their expertise and scope. Additionally, a set of keywords for each domain helps classify queries when confidence is low. A TF-IDF vectorizer compares the query against domain keywords to determine the most relevant domain. The determine domain method identifies the most relevant domain for a query using 2 approaches. The primary approach uses GPT to classify the query based on domain-specific prompts. The fallback approach applies keyword-based classification using TF5 and cosine similarity if GPT confidence is low or less than 60%. When the script runs, a user asks a question like, "Explain how mRNA vaccines work." The system analyzes the query, determines the healthcare domain, and provides the confidence score. Now let's ask a question for finance, such as, "What factors should I consider before taking a mortgage?" The system identifies that the query belongs to the finance domain and provides the relevant results. MOE has diverse applications, such as multi-domain question answering, e-commerce recommendations, multilingual NLP applications, etc. Stay tuned for more tutorials on GenAI. Thank you for watching.